Hello, this is Mr. Warner, 2nd grade Chillicothe Online Options Program instructor. We are so glad to have you here today, as today's lesson is definitely going to be a fun one. Let's go ahead and get started with our lesson objectives. Students will apply knowledge of science content to real-world challenges, plan and conduct simple scientific investigations using appropriate safety techniques based on exploration, observation, and questions, predict the changes in motion that a moving object or an object at rest experiences when acted on by a force, push, pull, gravity, or catapult. We have provided a recording sheet on Class Dojo. Students can also record their data on a blank piece of paper. So you need to have either this sheet in front of you or a piece of paper and something to write with. So let's get started. The first thing that we see on our recording sheet is a thing that says testable question. This is what we are going to be trying to answer in our experimenting today. It says, how does the size of the pumpkin affect the distance it travels when launched by the catapult? To test our testable question, we need certain items. We need pumpkins of different sizes, and we also need access to our catapult. So, what do you think? This is where we come to our hypothesis. Our hypothesis is our educated guess, which means, what do you think is going to happen? Which pumpkin do you think is going to go the furthest? Which pumpkin do you think is not going to go very far at all? And why? At this time, with the help of your teacher, write your hypothesis on the STEM paper or on a blank piece of paper. The next element of our STEM recording sheet that we are going to be talking about is the data part. The two data points that we are going to be recording for this experiment are the size of the pumpkin and the distance it travels. Since the first data point that we are going to be recording today is the size of our pumpkins, let's take a moment to look at the pumpkins that we will be launching in today's experiment. We have pumpkin A, pumpkin B, pumpkin C, and pumpkin D. Pumpkin D?
One of these things is not like the others. One of these things doesn't belong. Can you tell which thing is not like the other by the time I finish this song?
Well, yeah. Anyway, as you can see, pumpkin A is our smallest pumpkin, followed by pumpkin B, and then pumpkin C, and, well, pumpkin D's a pineapple, but we'll launch it anyway, just for fun. It is now time to record some of our data. At this time, draw a picture of each pumpkin, showing its size compared to the rest of the other pumpkins. Pumpkin A should be the smallest pumpkin, and pumpkin C should be the largest, with pumpkin B being somewhere in the middle. Pumpkin D should still be included for fun. The line underneath each pumpkin will be used to record the distance traveled later in our experiment. Now let's talk how we are going to set up for our experiment. Setting up is simple but important, as a catapult is a powerful tool that, if used incorrectly, could hurt somebody. So we took our catapult out to the Mount Logan parking lot and made sure that there was nothing downrange that would be affected by the catapult. And as you can see, after some quick setting up and moving our pumpkins into position along with our skeleton friend, we are ready to begin. So sit back, relax, but get ready. Let's chuck some pumpkins!
3, 2, 1.
Now that we have launched our pumpkins, we need to record how far they traveled. As we were launching the pumpkins, we were marking where the pumpkin landed, not where the pumpkin landed and rolled. At this time, go ahead and write with your teacher how far each pumpkin went. Make sure you write the number of feet your pumpkin traveled underneath each drawing. As we can see, pumpkin A went the farthest with 38 feet traveled. Next was pumpkin B, who went 22 feet, followed by pumpkin D at 11 feet, and pumpkin C traveled the shortest distance with 6 feet. Conclusion. Discuss with your teacher how your data compares to your hypothesis. Write your conclusion with the help of your teacher. Remember, it is a-okay if your data does not match your hypothesis. As we are wrapping up, one thing we did not expect was how well the pumpkins would survive being launched. Let's change that.
Oh! Alright, 1, 2, 3. It does. Here, record me. I'm gonna bust it. Make sure you can see a little bit of the ground still. So
Okay.
do it like right in front of me.
Alright.
Ready?
Yeah.
3, 2, 1.
Oh! Oh no! Look at it! That's cool.